This is MATHguide.com, and my name is Mark Karadimos. In this video, we're going to talk about rational expressions, and we're going to graph them as transformations. In our first section, we're going to go over the properties of rational expressions and talk about what the curve looks like, what the base curve looks like. And then in the following sections, we're going to go over 3 examples. Let's get started. Right now you're looking at the curve of what a rational expression looks like. And this is the base curve of what it looks like. You'll notice that as the curve goes to the right, it's getting closer and closer to the x-axis. So we call the x-axis an asymptote. It's a curve, or in this case a line, that helps you graph this curve. So this blue curve follows the x-axis as we go farther to the right. It's even true here for this branch. As we are a little bug and we go to the left, we're getting closer and closer to the x-axis. Okay, so that's why this x-axis is an asymptote, and also we have a vertical asymptote. As we get closer to, as we go up the curve, in this case, as I'm going up the curve, I'm getting closer and closer to the y-axis. And it's true here too. As I go down on this, if we're looking at this bottom curve and we're going further and further down, we're getting closer to the y-axis. So the x-axis and the y-axis are something called asymptotes. So this is what the base curve looks like. What we're going to do is we're going to change this equation, and we're going to see what the effect is on the graph. Okay, so that's what these examples are going to look like in the next couple sections. All right. So here's our first example. So in this example, we're supposed to sketch the graph of y equals 1 over x minus 2 minus 1. Okay, so let's take a look at what happens with this equation. As a transformation, when I look at this denominator, I notice that what was originally an x down there in the base curve has been replaced with an x minus 2. So anytime I see x being replaced, that is, with x minus 2, I know it's going to be shifted 2 units. The question is, do I move it horizontally 2 units left or right? And it turns out that even though we see this minus sign, it's actually the opposite direction. So that means I'm going to take the base curve, which I have right here, and imagine taking this vertical asymptote and moving it over 2 units right. So if we did that, the vertical asymptote would look, well, kind of like this. And also I have a minus 1 out here. When you have a minus 1 out there, it's going to move the horizontal asymptote vertically 1 unit. Which direction? Well, we don't go the opposite for this one. We're actually going to go down 1. So horizontally, we do the opposite move. So if you see a minus 2, we move 2 units right. If we see a minus 1 here on the outside, we don't do the opposite. We go down 1. So our horizontal asymptote is going to look like this. Okay, so now how do we graph it? Well, the curve is fairly easy to graph, which I'm going to try to do in blue here. It pretty much looks like the same curve, except now it's going to follow these asymptotes. So the curve is going to do this, and then the curve is going to do this. Now, I have to caution you that I don't know where this x-intercept is. I could find it with doing some mathematics, but this is just a sketch. I really don't know where that point is yet without doing some math. Likewise, I don't know what the y-intercept is here without doing some math. But I'm not going to concern myself with that at the moment. I just want to get a general feel as to what this sketch looks like. Okay, and there you have it. We have the sketch of this curve. Here's our second example. So you notice here, first of all, that our denominator is no longer an x, it's a x plus 1. That means we're going to take the vertical asymptote and we're going to move it 1 unit. And we're going to move in the opposite direction. So whatever that says, instead of going right 1, like you think with a plus 1, nope, we do the opposite. We go left 1. So now I know that the vertical asymptote is right here. Well, trying my best there to make that vertical. And then here you can see that I've got a plus 3. So that means I'm going to take the horizontal asymptote and I'm going to move it up 3. So I do not do the opposite when it comes to the vertical. Okay, so there you go. There's my horizontal asymptote. There you go. Vertical up and down, horizontal left and right. Okay, so I moved the horizontal asymptote up 3 units. This is what the curve looks like. But now we've got a new wrinkle in our equation, which is the minus sign. Now, what does the minus sign do? See, normally the curve would be up here and down here, but this minus sign flips it across the horizontal asymptote. So instead of it being up here, it's going to be flipped down here. Oops, which I'm going to do that in blue. So it's going to look like this. Now, I'm really just estimating what this curve looks like. Does it really go through the origin? Probably not. But I do know the curve is down here somewhere. I do not know where the x and y intercepts are. Okay, that's just an estimate. Okay, now instead of this blue curve being down here, it's flipped across the horizontal asymptote and it's going to be over here. So in other words, I know it's going to be in this section. So it'll have this look. Now, what does the 2 do to the curve? Now, I didn't really factor it in here too much, but what it's going to do is it's going to stretch the curve vertically. So it makes it grow, kind of stretching like taffy. You stretch it this way, and it kind of stretches farther away from the horizontal asymptote. Again, it's kind of hard to guess what that is. I'm not going to do it. I'm just going to estimate what the curve looks like. If we wanted more detail, we could throw this in a graphing calculator. We just want to get an idea what the curve looks like and what its shape looks like. So this way we could find, like, let's say the end behavior of what this curve is or has. Okay, let's go on to our third example. All right, so here we have our third example. We have a function that is shifted 3 units right, 1 unit up, and it'll be reflected over the x-axis. And we've got to come up with an equation that models this behavior, and then we're going to graph it. Okay, so normally the curve looks like this, which is y equals 1 over x. However, now the equation is going to change. Okay, so we're still going to have the 1, but what's in the denominator? Well, we're going to move the curve 3 units to the right. So I know you're tempted to put a plus 3 because you think right is positive 3, but it's always the opposite with the vertical asymptote. So it says 3 units right. I'm going to put a minus 3 here. Okay, also it says I'm going to move the curve 1 unit up. So out here I know there's going to be a 1. The question is it plus or minus? If you're moving the horizontal asymptote up 1, it's going to be a plus 1. So how does this reflection over the x-axis work? If you reflect it over the x-axis, in other words, you do this flip of this curve, there's a minus here. And it really doesn't matter where you put it. You could put it right here, or you could put it in the numerator. It doesn't matter, so I'm going to leave it right there, even with the fraction bar. Okay, so that equation is going to model this motion and this movement. Okay, so let's try doing it. Let's move the curve 3 units right, and that's what it says to do. All right, so I'm going to go 1, 2, 3, and that means that's where the vertical asymptote's going to be. I'm going to move the curve 1 unit up, so that's where the horizontal asymptote's going to be. Okay, so normally the curve would be like you see in the top right and the bottom left, except this is being flipped over the x-axis. In other words, we're flipping it over the horizontal asymptote. So the curve is going to look instead like this. It's going to follow those asymptotes, and then it's going to follow these asymptotes. It's going to have this general shape. Where does it cross the y-axis? I don't know. I could do some math. I don't know. I don't know where it's going to cross the x-axis either without digging into the equation a little bit. But anyway, that's what the curve looks like. And so we have an equation. We've got its graph. We've got the statement there, the transformation statement. They all match up. Okay, so I'm glad you checked out the video. Please like the video, subscribe to the channel, and make sure you go back to mathguide.com, check out our text-based lessons, our interactive quizzes, and instructional videos. Have a great day.